2 farad, 4 farad. We have to calculate the charge on all capacitor. This is circuit given. Shall we go for division of charge? I think a little bit trouble, no, here, because only one cell, the charge of cell should be conserved. Now you have to divide charge in such a way that charge of each cell must be conserved. You try it a little bit, it will be very time consuming one. So instead what happen, we can go for an alternative nodal analysis. Find charge in all capacitors. No initial charge. No initial charge. In the circuit. So for zero potential, so I'll start with this one. Let this be 0 volt. Then this should be 20 volt. If this is 20 volt, this should be 40 volt. Here we are assuming it, then this should be 10 volt. Then the potential of this be Vx, potential of this be Vy. Try to see once all. Now, how many unknowns are there? Vx and Vy. I think once you get Vx, Vy, the rest of everything you can manage. So here Vx. All of you getting the idea? So, sir, why you started 0? Why don't you start here 0? Yes, you can do it. Sir, why don't you make this is 0 volt? Means why don't you write 0 volt? Yes, you can do it. So I just took this is 0 volt. The drop across a cell should be 10. This potential difference across the cell should be 20. This should be 20, no? So therefore 40 minus 20. These are unknown things, Vx and Vy. So then writing the equation, Vx minus 10 into 2, Vx minus 0 into 4. Now look at this, charge at x, this is at x. So solving this, 2Vx, 4Vx, 4Vx, 10Vx minus, this will be 4Vy minus 20 equal to 0. This is the one equation. Similarly, at y, Vy Vy minus Vx into 4 plus Vy minus 40 into 4 so 10 Vy minus 4 Vx, this will be 160 minus 200. Solving 1, 2 will get Vx, Vy. Then once you know Vx, Vy, we can get the charge in all capacitor. I think this will be much easier, no? So you do one thing, I show nodal analysis. Try with the distribution of charge. Definitely you feel some lot of inconvenient. So unnecessary. We have to more focus. We have to put more effort. And charge at isolate junction must be conserved. So I think there are two junctions are there. You have to be very careful. Means charge of these two must be conserved. So if I write this, charge of these 3 plates must be conserved when you are again distributing charge. So these are the headaches, no? Therefore, we are going for the nodal analysis. Nodal analysis, there won't be much risk for you. Only thing is you have to define the potentials properly.